Assalamualaikum. My name is Nur Alia binti Hazrin. My student ID is 2023-660476, and in this case study, my group and I will be discussing about emission from agricultural activities.
My name is Naimiliana binti Muhammad Rossi, and my metric number is 2023867684. So I will start with the introduction and explain what agriculture emissions are. So agricultural emissions refer to air pollutants and greenhouse gases released from farming activities. These emissions are not from a single source, but come from various agricultural practices. So they are emitted from crop production and soil management. So livestock farming, especially through a process called entry, fermentation, rice cultivation, as well as from the fertilizer use and agricultural machinery. So one important characteristic of agricultural emissions is that they are mostly diffuse, meaning they come from many small sources spread over large areas. So because of this, they are difficult to monitor and control compared to emissions from industry or vehicles. So overall, agriculture is considered a major contributor to non-industrial emissions, especially greenhouse gases. So in terms of significant agricultural emissions play an important role in environmental problems. Globally, agriculture contributes around 20 to 25% of total greenhouse gas emissions. So these emissions contribute significantly to climate change. So affect air quality and human health. So and cause environmental problems such as global warming, ecosystem damage, and acidification and smoke formation. So there are several main types of agricultural emissions, including methane, ammonia, carbon dioxide, nitrogen oxides, particulate matter, and pesticide drift, which will be explained further in the next session. Next, I will discuss the background data for agricultural emissions at the global level and in Malaysia. So globally, agriculture contributes 20 to 25% of greenhouse gas emissions. The major sources are livestock, farming and rice cultivation, and the dominant gases are methane and nitrous oxide. So in Malaysia, agricultural emissions mainly come from key sectors such as rice farming, oil palm, plantation, and livestock production. Methane is largely emitted from floated rice field. Ammonia is released from fertilizer use, and carbon dioxide is produced from agricultural machinery. So when we compare both global and Malaysia contexts, we can see that livestock and rice cultivations are important emissions sources in both cases. So however, Malaysia shows a stronger influence from fertilizer use and machinery emissions, reflecting local agricultural practice.
Assalamualaikum and good day. My name is Farah Fadila from AS2455M3. So today I will be presenting my part, which focuses on the environmental issues, data and also analysis related to emissions from agricultural activities. So first, I will talk about environmental impacts of agricultural emissions. For this slide, I will explain the main environmental impacts of agricultural emission. Agricultural is a major non-industrial source of air pollution. Emissions mainly come from open burning of crop residues, fertilizer application, and also livestock farming. These activities will release harmful gases such as ammonia, methane, particulate matter, and nitrogen oxides. As a result, agricultural emissions affect air quality, also human health, ecosystem, and contribute to climate change. This pie chart shows the distribution of global methane emissions by sector. Agriculture is the largest contributor, accounting for 40% of global methane emissions, This mainly comes from livestock digestion and also rice cultivation. The energy sector contributes 35%, followed by waste at 20%, and other sources at only 5%. So here we can see clearly that agriculture plays a major role in methane related to climate impacts. Alright, next, this slide shows a case study from Kedah, Malaysia, focusing on paddy field burning. For the background, open burning of rice straw is commonly practiced after paddy harvesting to clear fields quickly. The practice continues mainly because it is low cost and requires minimal labor and equipment. Okay, so basically paddy field burning usually happen after harvesting season to prepare the land for the next planting cycle. So however, this open burning will release smoke and also particulate matter into the air and leading to air pollution and also environmental degradation. From this bar chart compares PM10 levels during non-burning and also burning season. Okay, during the non-burning seasons, PM10 levels are around 40 micrograms per cubic meter. However, during the paddy burning season, PM10 level increase sharply to about 90 micrograms per cubic meter. So here we can clearly say that open burning of paddy fields significantly worsens air quality during harvesting periods, as well as it can increase the health risk for the nearby communities.
The first strategy is livestock emission. Livestock farms in Malaysia, such as cattle, dairy, poultry, contribute to methane and ammonia emission. Methane is produced during enteric fermentation in ruminants, while ammonia is released from improper manure management. To mitigate these emissions, strategies such as improving feeding particles, the use of feeding additives to reduce methane formation, and better manure storage and treatment that can be applied. To compare with previous research, according to the IPCC and FAO, livestock farming is one of the largest contributors to agricultural methane emission. Previous studies have shown that feed modification and improved manure management are effective in significantly reducing methane and ammonia emission. Therefore, the mitigation strategy proposed here are consistent with and supported by previous research. The second strategy would be fertilizer and soil management. Inefficient use will release potent greenhouse gases, while poor management degrades soil, releasing stored carbon and harming water quality. Mitigation strategies include optimizing fertilizer application, using slow-release fertilizers, and improving soil management practices. To compare with previous research, IPCC and FAO report highlight that efficient nitrogen management is a key method to reduce ammonia emission from agricultural. Studies have shown that precision fertilizers use can lower emission while maintaining crop yield. This shown that the fertilizer mitigation strategy proposed in the study align well with established scientific findings. Third strategy would be about crop residue and open burning. Open burning of paddy straw is practiced in some rice growing area, such as Kedah Perlis, that can release particulate matter, carbon monoxide, and contribute to haze episode. To reduce this emission, open burning can be replaced with no burn practice, such as mulching, composting, and mechanized residue management. From previous research by FAO and PICC identifies open burning of agricultural residue as a major source of particulate air pollution. Studies have shown that no burn practices significantly reduce particulate emission and improve regional air quality. Therefore, the proposed mitigation strategies directly address the problems highlighted in previous research. Lastly would be about technology and policy measures. In addition to farm-level practices, technology and policy measures play an important role in emission reduction. Precision agricultural technologies help to optimize resource use, while emission monitoring ensure compliance with environmental regulations. Government policies and farmer education programmes are also essential to encourage the adoption of sustainability agricultural practices. According to OECD, FAO, and IPCC reports, integrated approaches that combine technology, policy support, and education are more effective than single mitigation measure. This confirms that a holistic approach is necessary for a long-term emission which can reduce in agricultural activities. It is recommended that low-emission agricultural practices be more widely adopted in Malaysia. Enforcement of open burning regulation should be strengthened, and livestock waste-to-energy technologies such as biogas system should be encouraged. Future research should focus on cost-effective mitigation technologies that are suitable for local farmers and continuous monitoring of agricultural emission to improve control strategies. In conclusion, agricultural activities are a significant source of air pollutants such as methane, ammonia, and particulate matter, which contribute to air pollution and environmental degradation. This study demonstrates that these emissions can be effectively reduced through mitigation strategy, including improved livestock management, optimized fertilizer use, and the control of open burning practices. Comparison with previous research from organizations such as the IPCC and FAO confirms that the proposed mitigation measures are significantly supported and effective. Therefore, the adoption of sustainability agricultural practices is essential for improving air quality and achieve long-term environmental sustainability. In this slide, you can see the reference that we use to determine the case study of emission from agricultural activities. That is all from us. Thank you.